Did you know? A commercial jet descending through golden sunset clouds. There is something magical about watching an aircraft descend from the sky. After hours of cruising at 35,000 feet, slicing through thin air at nearly 900 kilometers per hour, the aircraft must return to Earth. But landing is not simply coming down. It is one of the most complex, calculated, and skill-intensive phases of flight. In fact, many aviation professionals consider landing to be the most critical part of the entire journey. Long before passengers feel the wheels touch the runway, the landing process has already started. Air traffic controllers guide the aircraft toward its destination airport. Using radar and precise separation rules, they coordinate dozens, sometimes hundreds of aircraft moving through the same airspace. Inside the cockpit, pilots program the descent into the flight management system. The aircraft doesn't simply drop. It follows a carefully calculated vertical path, balancing speed, fuel efficiency, and airspace restrictions. As the engines reduce power, the aircraft begins a gradual descent, typically at about 1,500 to 3,000 feet per minute. Passengers may feel a slight change in engine sound. The cabin crew prepares the cabin. Seatbelt signs illuminate. The approach phase has begun. The approach, precision in motion. As the aircraft nears the airport, things become more dynamic. Pilots receive instructions from the control tower headings, altitudes, and speeds. They must align with a specific runway, sometimes while managing wind, turbulence, or heavy traffic. Modern aircraft rely on the Instrument Landing System, or ILS. This ground-based system transmits radio signals that guide the aircraft laterally and vertically to the runway centerline. When visibility is low during fog, heavy rain, or night, ILS becomes essential. In some aircraft, such as the Boeing 737 or the Airbus A320, autopilot systems can even perform automatic landings under certified conditions. But even with automation, pilots are fully engaged monitoring instruments, cross-checking data, and preparing for manual control if needed. Configuring the aircraft. Landing requires the aircraft to slow down significantly. Cruise speed may exceed 800 km per hour. Landing speed, however, is often between 240 and 280 km per hour, depending on aircraft type and weight. To achieve this, pilots extend flaps movable panels on the wings that increase lift at lower speeds. Slats on the front of the wings deploy as well, improving aerodynamic performance. Landing gear is lowered, creating additional drag and preparing the aircraft for touchdown. Each step follows a checklist. Every movement is verified by both pilots. There is no room for improvisation. Now the runway is in sight. Or perhaps not. Perhaps it's hidden in clouds, relying entirely on instruments. The aircraft descends along a glide slope of approximately 3 degrees. This angle is standard worldwide, balancing safety and passenger comfort. Pilots make small corrections using the control column and rudder pedals. Crosswinds can push the aircraft sideways. Skilled pilots counter this by slightly angling the nose into the wind, a technique known as crabbing. Moments before touchdown, they straighten the aircraft with precise rudder input. All of this happens within seconds.